All right, we are back. Hopefully this will um, go through now. Um, After this one, you'll see a picture of the gram positive and gram negative. It's just, we know that's bacteria. And then the next slide is the culture and sensitivity, which again, I didn't want to copy on this recording. So now we'll move into fungus. What is that, or fungi? Um, most fungus are non-photosynthetic synthetic microorganisms that produce by division. They are very large compared to other microorganisms, contain a true nucleus, and they're classified either as yeast or molds. And you can read a yeast, round single cell, live with or without oxygen, and mold is aerobic, so it's going to need oxygen. Part of normal flora, but it can overproduce. Vaginal yeast infections are when antibiotics are used secondary to destruction of the normal flora, allowing yeast to reproduce. And that's, of course, the normal flora. And when we take a very potent antibiotic, it can knock a lot of the organisms out that need to be in that area to make it normal. And so that's why women get yeast infections. Infections caused by fungus are called mycotic. And most infections are mild unless they become systemic, meaning throughout the body. There's fungus Candida albicans is the most common cause of fungal infections in humans. Candida is Candida. Albicans is Albicans. And it resides in the skin, GI tract, mouth, and vagina. Can cause vaginitis, or it can an oral pharyngeal, which is the mouth and throat infection. A lot of times we refer to that as thrush. Most common fungal infection for people are the ones who have cancer, because again, we're wiping out their white cells, and HIV, same thing. They're immunosuppressed people. Parasites, uncommon except in hot, moist climates. So, we're hot here, but we're not moist, so that's good. They could be single-celled or multi-celled organisms that depend on a host for food and protective environment. Most common parasite infections occur in the intestines for human beings are tapeworms, and kids have them way more than anybody else. Persons with healthy immune systems. Oh, and then there's a picture of the Trichomonas, the vaginal parasite, and you can see it's fairly large. And they were saying that they are larger than bacteria and virus parasites and yeast. Barriers to infection. We know anybody with a healthy immune system can ward off infections. Hopefully, we know skin, all of these, we've gone over and over them. But what I wanted you to take home from this screen is the secretions contain bacteria-killing particles called lysosomes. So any of the secretions from our eyes, nasal passages, prostate, testicles, stomach, vagina, and that's what will break up whatever is trying to harm the area and keep it out of the body. And then there's relationships that exist between humans and organisms, and these words all belong to this area. Symbiosis, it benefits only the human, where commensalism benefits only the organism, but there's no harm to the human in commensalism, so that's okay. Symbiosis is the opposite of commensalism, benefits only the human, no harm to the organism, but it can be maintained or manipulated by the immune and inflammatory systems. Mutualism benefits the human and the organism. Pathogenicity is what we're going to be talking about in this class. It benefits the organism but harms us. And then an opportunism we will be talking about also. It's benign human organisms become pathogenic because of the low human host resistance. And so how do we get this way? We say an organism is opportunistic for somebody on chemotherapy because they have a diminished human host resistance. It's diminished somehow. Or any autoimmune disorder, they may have a low human host resistance. We have septicemia, can result from proliferation of bacteria in the bloodstream. Toxins released from blood-borne bacteria cause the release of vasoactive enzymes that increase the permeability that we talked about a lot yesterday of blood vessels, so it allows microbes to go in much easier. It also allows leakage from the vessel, which causes hypotension because of our volume, and it can result in septic shock or multiple organ failure. And so this would be, septicemia would be an example of pathogenicity. How does infection progress? Well, we have direct damage to cells. We have interference with the cellular metabolism because the cell's damaged, rendering a cell dysfunction because of the accumulation of pathogenic substances, and then a toxic production. Infection by pathogens are influenced by all of these terms. Infectivity is the ability of the pathogen to invade and multiply in the host. Pathogenicity would be the ability of an agent to produce disease. Success depends on the speed of the reproduction. You heard in the film, it takes a while for our body's immune response to kick in. The extent of tissue damage, is it localized or is it in a much larger area? Production of toxins, what does it actually give off? And then the virulence means strength. It's how strong is it? It's the potency of a pathogen, measured in the number of micrograms of a toxin required to kill the host. Measles has a very low virulence. We can actually kill it. Rabies has a high virulence. It's to the point where if you get rabies, we can't turn it back unless you get in there very, very, very quickly after an animal that's rabid bites you. Immunogenicity, what is that? It's the ability of pathogens to induce an immune response. And so one of the example I have for immunogenicity would be there's a syndrome called DiGeorge syndrome. It's capital D-I and then George, capital G-E-O-R-G-E. It's characterized by complete or partial lack of the thymus gland. And we know, remember from yesterday, the T cells mature in the thymus gland. So we've got a diminished T cell immunity, frequently associated with diminished or absent parathyroid gland activity, resulting in hypocalcemia and cardiac anomalies. So again, it's a syndrome. So it's not just one thing. So we've got cardiac anomalies with DiGeorge syndrome. We've got low calcium because of the problem with the parathyroid glands that sit, on the thyroid, and they're responsible for calcium metabolism. But the main problem with DiGeorge syndrome is it's got a lack of the thymus, resulting in diminished T cell count. And just by that silly cartoon, you saw how important the T cells are. Okay. Infection by pathogens, again, is influenced by not only all of these, but toxigenicity is the ability to produce disease by production of a soluble toxin. Hemolysin, there's a lysine, destroys erythrocytes. And you can look at the heme is going to mean blood. Leucose is always going to mean white cells, destroys white cells, leukocytes. Both are products of streptococci and staphylococci, bad bacteria. They're very, very toxic. That's what this all is saying. Portal of entry is how do they get in? It's the route in which the pathogen infects the host, and we're the host, human beings. Direct contact, inhalation, ingestion, or bite. Direct contact is what we're going through right now. That's why they're saying wash their hands. But it's through breathing this COVID-19 and it's the new mutated version by inhaling it. But there are other pathogens that where we have to ingest or bite would be rabies or anything from an animal, and human beings too. Other human beings can cause toxins by the bacteria in their mouth if they bite somebody. And here it is. Spread of infection is facilitated by the ability of the pathogen, which is the bacteria, virus, parasite, a fungus, yeast, it's everything we've been looking at, to spread through the lymph and blood and into tissue and organs where they multiply and cause disease. Stages of infection, and look at all of them. We've talked, and most of you know what a prodromal and an incubation period is if you went through microbiology, but we're just going to talk about it. Incubation period is the period from the initial exposure to the infection and the onset of first symptoms. And we've been talking a lot about this in the past year with COVID. And they'll say, you hear 7 days, you hear 4 days, I've heard 10 days. And then some people are just on the conservative side, and they're saying you got to stay home for 2 weeks. So because we don't really know. We know incubation periods from other things that have been around for years and years. The prodromal stage follows the incubation period. It's where the initial symptoms, and they can be mild at this point, include a feeling of discomfort and fatigue. Pathogens continue to multiply. Sometimes you're just tired. All of a sudden you're saying, I'm just way more tired than I usually am. And then boom, hours later you're sick. And that would be this one. Invasion or acute illness. Pathogens are multiplying. They've been multiplying here, but now they're multiplying at a rate where it's invading the tissues. Your fighters should be in tow at this point. And then convalescence is the resting stage. It's where our immune and inflammatory systems successfully remove the infectious agent through all of the chemical things that we looked at yesterday and physiological that are going to help us. And symptoms decline, or the disease may be fatal if people if they're not okay. To go back to the incubation period, we talked about COVID. Chickenpox is 21 days. Long incubation period. Let's see. Okay. And then vaccines induce primary and secondary immune responses under conditions that will not cause disease. They should not make you sick. Most bacterial vaccines are killed microorganisms, where viruses are live viruses that are weakened or attenuated. And attenuated just means weakened in force or effect, because they're not going to give you a virus that's going to make you ill. That's not the idea. They express appropriate antigens that cause only a limited and easily controlled infection. You might feel a little tired, that type of thing, but you won't get ill. Examples of the ones we have: MMR, measles, mumps, and rubella, varicella, chickenpox, polio vaccine, and of course now the COVID-19 vaccine that is so controversial. Vaccines, and you can see the picture of the horses. That was my herd immunity. And then also talking about pneumococcal, there are 10 different strains of S. pneumoniae that there's hundreds actually, but these 10 cause the most severe illness. It contains killed bacteria and extracts of bacterial antigens, and they highly recommend, if you're 65 and older, that you get this along with the flu shot. Very, very important if you have your parents and grandparents. They need to get this because pneumonia still kills people. At any rate, we know herd immunity is when we try to immunize 85% of the population in order to achieve protection for the total population. And in America right now, I've heard we're between 50 and 56% with this COVID. And again, we're just drawing it out because people will not go get vaccinated. Rubiola vaccine was produced in 1963. Parents became complacent with their preschoolers. Between 1989 and 1990, we had an outbreak in the United States with some deaths due to measles. So the government at that point put rules in place that children could not attend schools if they weren't vaccinated. And that didn't help too much, because in 2008, the number of measles increased fourfold because of the parents' resistance to immunize. So there you have it. I don't even know what to say about that. And then here is just an example of cell wall inhibitors, cell wall membrane inhibitors, inhibitors of DNA, inhibitors of protein synthesis and assembly, and metabolic analogs. And all an analog is, it's a structurally modified metabolite that prevents the action of the normal metabolite. So basically what that means is it does not let the microbe metabolize. And you do not have to, I just gave you this for your information. I want you to know what we talked about with antibiotics yesterday. And then antibiotic resistance, we know how it happens. Overuse of antibiotic leads to the destruction of normal flora, allowing the selective overgrowth of antibiotic resistant strains or pathogens. And causes of antibiotic resistance, you can go ahead and read through these. I think a lot of these we talked about in the ticket to class. Then we'll just finish with an NCLEX question. What do you think of this one? After studying about viruses, which information indicates the student has a good understanding of viruses? Well, we know they contain DNA and RNA, and they're are they capable of independent reproduction? No, they're not. They need to get inside the cell. And they are not easily killed by antimicrobials, right? So that leaves us with answer C. They replicate their genetic material inside the host cell. All right, that's all I got for this one, and good luck with your studying. You do have a study guide, and I will see you after Labor Day, or I have office hours next Tuesday too. Talk to you soon. Bye-bye. Have a great holiday.